Energy also comes in different flavors. We're going to be most concerned with a couple of flavors of energy. One of them is electromagnetic radiation. There's a whole spectrum of radiation waves which fall into the electromagnetic spectrum. These have different wavelengths. There are some wavelengths that are very short. These are extremely high energy packets of electromagnetic radiation. There are some wavelengths that are very long. These are low energy packets of radiation. When electromagnetic radiation hits matter, it can be bounced back, it can pass straight on through in some cases, or it may transfer energy to that matter. That, by the way, is why these types of energy are dangerous. When they hit matter, they can transfer a lot of energy to that matter, and they can break apart chemicals, including things like your DNA. And that's why all of these types of radiation can cause cancer. These types of radiation cause much less change when they hit matter. Infrared waves will just cause the atoms to jiggle around a little more, and that's what we know of as heat. Sometimes, when energy hits matter and then it's absorbed, it can then be re-radiated, but it often comes out as a different wavelength. Here's a strange thing that you may not have known. There are some animals that glow under ultraviolet light. Scorpions, for example, glow under ultraviolet light. Why do things glow when you put them under a black light? Well, what's happening is you're bathing them in energy that you can't see, ultraviolet energy. And some materials absorb the ultraviolet, and then they re-radiate it. They kick it back out in the visible light spectrum. So they take in a wavelength that's up here, and they kick back a wavelength that's somewhere around here in the blue. Okay, the same thing often happens with heat. So for example, if you've got a dark-colored rock that's out in the sun, it's absorbing the visible light, sort of all the light spectrum that's coming in from the sun, and it's re-radiating that energy as infrared, as heat. Okay, on to the next flavor of energy. Chemical energy. There is potential energy in the bonds between the atoms in every molecule. Now, potential energy you can sort of think of as energy that's stored. It's like a spring that's been compressed. The energy isn't doing anything right now, but if it's released, it can do work. It can cause something to move, for example. Molecules can then be thought of as a little bit like batteries, except that you can't get the energy out without changing the battery into something else. This may feel a little counterintuitive, but what happens is that these atoms like being together, basically, in a molecule. And so you have to put energy in to break them apart. It takes a certain amount of work to pull those atoms apart. When you put two atoms together, they're happier. And so what they tend to do is they release energy. It's like letting a ball roll down to the bottom of a hill. That potential, there's sort of a release of kinetic energy, basically the energy of motion as the ball rolls downhill. In the same way as you put two atoms together into a molecule, they release energy. When you change from one kind of bond to another, you can potentially release a lot of energy. This is what happens when your body burns fuel, or for that matter, when something like your propane stove burns fuel. This is propane right here. And when you break these CH bonds and replace them with CO bonds, you're releasing a ton of energy. That's how a propane stove cooks something. It gives off the energy that was stored in these chemical bonds as heat. Energy can be used to move stuff around. And some of the stuff can be really, really small. Even moving a single atom around costs energy. For example, what's shown here is the membrane to one of the nerve cells in your body. Your nerve cells only work because they are constantly pumping sodium ions out and pulling potassium ions in. Every time that these proteins, that's what these yellow things are, they're proteins that basically pump ions. Every time that they pump sodium ions out and drag in a couple of potassium ions, it requires kinetic energy. That energy comes from chemical bonds. Okay, so this is where your food is going. This is how you burn calories. A calorie is a certain amount of energy that you get out of your food, and it's mostly used to do stuff like pump ions from one place to another. Or when these cell membranes get damaged, it's used to fix the cell membrane. It's used to copy your DNA. It's used to make proteins. All these tiny little movements can only happen because they're powered by the chemical energy being converted into kinetic energy. Since there are about 37 trillion cells in your body, even these tiny, tiny, tiny little movements start to add up in terms of energy. And so you need a lot of energy every day just to keep your cells from falling apart. Technically, energy cannot be created or destroyed. But for the purposes of an ecosystem, it can be lost. Basically, what's happening when it's lost is it's not destroyed, but it's being converted into a form that is not accessible by living things. Generally, this is heat. Once energy is radiated away in the form of heat, living organisms can't use it anymore. It's been used up.